Welcome to Global Risk Community Chat. Today our guest is Peter Quell. I'm very happy to have you here today, Peter. Welcome.
Hello.
Hi. So before we get into our topic, can you shortly introduce yourself to our audience?
Yes, thank you for the nice introduction. My name is Peter Quell. I'm heading the portfolio analytics team for market risk and credit risk here at DZ Bank in Frankfurt, Germany. On a daily basis, we are considering issues around risk model and risk model methodology for Pillar 1 and Pillar 2 purposes for DZ Bank. DZ Bank is the second largest financial institution here in Germany.
Thank you for that short introduction as well. So based on this, what topic you would like to share with us today?
So today I like to talk about the role machine learning or AI may play within risk modeling, or the area where I'm coming from, risk model for regulatory purposes. And one special focus I want to put on the way in which noise, that simple term noise, will permeate all those analysis. And I will also ask myself, why didn't we have too much progress in implementing AI or machine learning in these areas? So that would be the rough plan for today.
Sounds very interesting because obviously we all know that now AI is very trending topic with like so many new things, even for personal users coming in. So, but of course, we are now going to be talking about more in the risk end of things. So, what are some key things when it comes to AI and machine learning in the field of risk modeling, and what else would you like to share about it?
Mhm. So, as I said, today I'd like to talk about one of the, let's say, conundrums when it comes to the application of machine learning or AI. I use these terms more or less synonymous, as in synonym terms, but what are some of the conundrums when it comes to the application of machine learning to financial markets data? So, on the one hand, there are quite a lot of successful applications that span from credit rating to credit or loan approval process to automated trading, fraud prevention, and anti-money laundering. And I guess machine learning and AI has proven a lot of success and had a lot of success in these areas. But there is at least one area where machine learning has not yet, let's say, not yet contributed too many innovations, and that is time series analysis for financial risk management. And just as a side note, because currently we are recording this during a hype around this ChatGPT application from OpenAI, I guess that situation will not change considerably through the use of ChatGPT, at least at the moment. We can see later, but at the moment, that is the status quo. So the main reason for the situation I described so far is rooted in the observation that financial time series are very noisy. They are usually non-stationary and they are quite short. When I say short, I mean financial time series are objects with, let's say, a few hundred to 1,000 observations, at least in the market risk area. And this is sometimes not enough for typical machine learning algorithms to train. Nevertheless, traditional machine learning algorithms, and I consider also, for example, long short-term memory applications used, I guess, in speech recognition quite successfully. These algorithms simply do not find enough data to draw any relevant or useful conclusion from those small and very noisy time series. And there is also no way to circumvent around this topic because that is the reality. You have to find a period of time in market risk, for example, where this financial data is relevant, and this may just comprise of a few hundred or so observations. And traditional machine learning algorithms are in danger of overfitting the data. The large noise component within financial data might then lead the machine learning technique to focus on irrelevant noise patterns. There's always noise in these data, and then I'm not so much interested in finding patterns of noise. I want to have the algorithm separate the signal from the noise. And of course, a clear indication of overfitting is seen whenever such an algorithm is performing quite well on training data, but the performance is deteriorating once it is applied to data the computer or the machine has not seen before. I know a lot of data scientists would now oppose and say that, of course, we have enough elements in our toolboxes to fight overfitting. Yeah, that's true. There are a lot of techniques to cope with overfitting, for example, learning curves and stuff like that. But the problem is, whenever you use these techniques, exactly in this moment, the next problem kicks in, and this is the non-stationary component. Time series in financial markets, characteristics like volatility or drift constantly change, and this sometimes renders those techniques to control for overfitting a little bit useless. So till now, I have been quite destructive, quite negative about the use of these data analysis techniques for market risk. But there may be a solution, and this is the so-called Kalman filter, which provides a quite clever way of separating signal from noise by using some sort of adaptive averaging over successive observations. I guess some people have heard about this technique. It is not considered, I guess, not considered as artificial intelligence or machine learning. It is around since, I guess, the late 50s or I guess even in the 40s. But the big application was the space program of the United States in the 60s. It has proven to be a good tool for half a century. And it's also quite successfully operating on the analysis of financial time series. The Kalman filter is quite fast and flexible due to its online characteristic. It's, so to say, it's processing data bit by bit and always updating its analysis. And of course, you could say this is some way of an adaptive scheme, which may also be considered as some sort of AI technique. But then I would call it some sort of ancient AI technique. As I said, this has been around for several years. It runs on the, so to say, on the smallest computers. And of course, there has been some people have given it some effort in order to develop this a little bit further. And this development was also, or could also be seen in parallel to the established techniques like long short-term memory and speech recognition, or some image processing techniques. Those extensions are called particle filters. They are more or less a generalization of the Kalman filter, but I don't want to go into technical details because we only have so much, a little bit of time left. But with these particle filters, you can overcome, for example, issues like a little bit more fat-tailed distributions. This is what people in the risk management are always talking about. What about change of assumption in the distributional sense? Or once it comes to nonlinearities, those particle filters, I guess, prove quite successful. But nevertheless, they are, once you have the basic idea of the Kalman filter, these are just small steps. The big step is recognize that there is already a tool there. It could be called AI. It could also be called ancient AI, or it could be called just the Kalman filter. But that is a good tool that separates signal from the noise. So at least in this context, I can be a little bit more positive. Coming back to my domain of expertise, it's risk modeling or risk measurement in a regulatory environment. And this regulatory dimension, of course, involves another important aspect, the explainability or interpretability of the algorithms. Within a regulatory context, you just cannot use a black box solution like a very, 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 very deep neural network that may come as a black box solution, even if that technique has a superb backtesting characteristic. It will not be allowed, or the regulator will not allow you to use it if you cannot explain what you are doing or what the system is doing. But in the end, the techniques I told you about, the Kalman filter or the particle filter, are by their nature interpretable or explainable, since they can be connected to state space models. And this is maybe a quite easy exercise to show how they are working and what they are doing. So I guess the explainability and interpretability issue would also be solved by using the solution I have just told you about. Mm. But as I said, the regulatory environment is quite, so to say, conservative, and one very good approach would be, and we also tried this here at DZ Bank. We tried to come up with, so to say, benchmark or challenger models that are used to validate the champion models or the regulatorily approved models. And with this benchmarking approach, you can also demonstrate that the adaptive methods, maybe based on the Kalman filter or whatsoever, are much more superior than the established regulatory methods for risk measurement within market risk. And maybe as time goes by, we will see that also these more innovative techniques may permeate the financial risk management or risk measurement community. So yeah, let's see as time goes by if these methods can solve one or the other problem.
Yeah, indeed. I mean, for now, it looks promising on the future, except all the negativity that, one day I believe we will be able to use AI more effectively, hopefully by overcoming many, issues that it currently comes across with. But yeah, we will just see. And especially in some areas, of course, it's a little bit slower than on the other ones, understandably, especially when decision making is very crucial. But since we are running out of time, I want to ask one last question very shortly. Would you be able to share any takeaway points, if it were even to be just one sentence? What would be something that people should be looking into, you think?
So one takeaway is, please consider that financial time series are noisy. So don't be fooled by the noise within those time series. And the main goal should then be try to separate the signal from the noise. And I guess AI techniques have potential to be useful here. But as always, when you use new techniques, you should know what you are doing.
Then thank you so much for that takeaway as well. And with that, that's the end of our time for today. So I want to thank you so much for joining us today, sharing this topic from many angles. I think many angles also that is not as talked about when it comes to the AI and its problems as well. So thank you so much.
Okay, thank you for hosting me in this format. Thank you.
Have a great day.
Thank you.